Alright, so your first problem is the rectangular floor. So remember, this is when you are trying to figure out how many tiles are in the floor. So if you need a visual, you can kind of look at that sort of picture. So it's a rectangular floor, so you should be zoning in on rectangles. 3 feet wide by 12 feet long, covered in square tiles that have a length of 7 inches. So we have the square, and then you have the rectangular tiles. Or no, I'm sorry, you have the square and then you have the rectangular room. Hopefully you realize that the sideline, the tile is in inches and the floor is in feet. So what we've been doing is converting the rectangular room into inches, which means you multiply by 12. So to find our area of the floor in inches, we would do 3 times 12 is 36 times 12 times 12, which is 144. So that gives us a total area of 36 times 144, 5,184 inches squared. Okay, so then you would come over and do your tiles. So the tile is a square, so you could do s squared, or 7 times 7, which equals 49 inches squared. And it says to round our answer to the nearest whole number. So those are our first 2 steps, and then you're going to come over here and do the total floor area divided by the total tile area. Okay, and that gets us to 105.7, which means we need 106 tiles if you round that up to the nearest whole number. Okay? Alright, and number 2, you're rounding to the nearest square inch. What is the area of a regular hexagon that has an apothem of 3 times the square root of 3 inches long? So the first thing I would do is write down my formula, 1/2 p times a, 1/2 of pi. Okay, so the p is the perimeter. So to get the perimeter, you first need the side length, which the trick is the side length is going to be 2 times the number in front of the square root. So the side length is 6. There's 6 sides since it's a hexagon. So the perimeter is 6 times 6, which is 36. So to find the area, you do 1/2 36 times 3 square roots of 3. So I'll show you how I would key that into my calculator. I would either put 1/2 in parentheses or just use 0.5 times 36 times 3 square roots of 3. And we're rounding our answer to the nearest square unit, so that would be 94. And it would be inches squared. Okay? Alright, number 3 is one with sector area. So the first thing I'm going to do is write down my formula for sector area. Sector area equals m over 360 times pi r squared. So we have a radius of 7 inches. The sector of the circle is 1.112 square inches, and they want to know what percent of the circle does the sector represent. So the first thing we have to do is find m. So I'm just going to substitute some values in that they give me. Again, we're trying to find m. Okay, and 7 squared is 49. Okay? Alright, and then the pi's are gone, and I'm just going to rewrite in order to help me, oh dear, let me go back, I forgot to put the m on the equation. Okay, alright, so we have m over 360 pi times 49, because that's r squared. And now we can cancel the pi's. And I'm going to rewrite this so we can see what we need to multiply by. 1.112 equals this is the same thing. 49 over 360 times m. So what I would do is multiply by the reciprocal. Okay. Okay, so come over to my calculator. You need to put it in parentheses. 360 divided by 49 times, what was it? 1.112. Enter. Okay, so then we get m equals 8.2. We'll round it to. And that's the m. So to get that percent, we have to do 8.2 of 360. Okay, so 8.2 divided by 360 is 0.0227, and then you can move the decimal over 2 spots and you get 2.27%. The one on your test will be a nice pretty fraction, which will make a nice pretty percent. Okay, all right, number 4 we have done a lot of, so I'm just going to start labeling. 6.25. I do want to make a note that you need to make sure you are finding the correct stuff. Okay, so the first thing it asks for is, what is the area of ABC? So I would make sure I know that area. The base of that triangle is 6.25 plus 1.6. So our base is going to be 7.85. Okay, so then what you have to do is you have to realize that we don't know the height of our triangle, but if you pull this little guy out, magically we have a right triangle. Okay, and you would use Pythagorean theorem to find that leg. I'm hoping you could do that on your own. If you want to do that on your own and then kind of pause the video, that might be a good idea. But that question mark ends up being 1.9. Okay, so then that's the height of your triangle. So what I would like you to do is calculate what the question wants. What is the area to the nearest square inch of triangle ABC? So here's your base, here's your height, and remember your formula is 1/2 base times height. So I will be around to check that answer. Okay? Alright, number 5, you definitely do not want to get wrong because it's super duper easy. Well, it can be. The area of the triangle is 46 square centimeters, so I'm going to hit 1/2 base times height. The length of one side is 4 and the area is 46. So and they want you to find the altitude. The altitude is just a fancy word for height. Okay, so you definitely should be able to solve for h here. Okay, 46 equals 2 times h, and then as I'm walking around I will be looking for your h value. So maybe number 4 and number 5 are 2 that we're definitely going to check for accuracy because I did not give you those answers. Okay, alright, and number 6 is your rectangular walkway. Okay, so here's our pool. You can see that the walkway is going around all sides. So the pool just has a width of, let's say, 10 up here and 14 right here. But then we're adding 2 feet to the left, 2 feet to the right, so that means it's a total of 4 feet being added. And then you're adding 2 feet to the bottom and 2 feet to the top, so that's another 4 feet being added. So the first thing I would do is I would find the area of the pool and the walk, so I call it PW. And that's going to be the new 14 times 18, which is 252. And then you find the area of just the pool, which is now just 10 times 14, which hopefully you can do that in your head. 140. So then you just want the area of the walkway, so you take your total and you take out the pool. Okay, and that gets us to 112 feet squared. Alright, so that's your first page. Your second page, I will let you know that this one will be, oh, that's huge, an extra credit question. So they give us two triangles, A, B, C. So if you're a highlighter, Alex, I know you're a highlighter, A, B, C. Okay, and then we have triangle D, E, F. So please note that there is some overlap. Okay, so what we're going to do is we're going to take our picture, we're going to label the given information. So A to D is 8, D to C is 6, and C to F is 4. Okay, what I'm going to have you do is you are going to find the area of ABC. Okay, so that's the yellow triangle. So ABC, that whole base is from A to C. So that's 8 plus 16. So the base is, what's 8 plus 16? 14. And the height is 8. So that gets us to 56. Okay. So then what you're going to do is you're going to find the area of DEF. Okay. So it's a triangle. So 1/2. Your base this time is going to be that guy. So D to F, which is 10. And your height is going to be the 4. Okay, so that should get you to 20. And then you have to find the area of the overlap, okay, which is going to be triangle GCD. That base is from D to C, which is 6, and that height is 1.8, which makes an area of 5.4. Okay, so what you do here, remember this is going to be extra credit. You're going to add the first triangle plus the second triangle, and then you're going to take out the overlap because you have accounted for that already, and you get, oopsies, 70.6. Okay, so remember this will be an extra credit question on your test. Alright, this is my favorite question of the unit. It's a new one. So it gives you a rectangle with an area of 21 square inches. If the length and width are whole numbers, what are possible perimeters? So what you have to start thinking of, what numbers in your rectangle could be your length and your width if they have to equal to 21. So the formula would be L times W. So what two numbers multiply to 21? Well, we have 1 and 21, and then we have 2 times a whole number won't get you to 21. You have 3 and 7. I don't think there are any other ones. So what you have to do now is find the perimeter using the 1 and the 21. So that would be 2 times 1 plus 2 times 21. 2 times 1 plus, whoopsies, 2 times 21. 44. Okay, and then you would do 2 times 3 plus 2 times 7, which I believe would get us to 20. So our possible perimeters would be 44 and 20. The more multiples there are of that number, the more possible perimeters you have. But since 21 only has 1 and 21 and 3 and 7, those are our only possible perimeters. Okay? Alright, number 9 is not a fun one. I'm just letting you know. So, it's asking for the area of a rhombus, which we know that formula is 1/2 diagonal 1 times diagonal 2. Okay, so if I start with my rhombus, it's a square on a windy day. So every side is 15. Okay, and one of the diagonals is 16. So what I'm going to do is, we already know that it's going to be 1/2 times 16 times something else. So we're going to have to find that other diagonal. The great thing about these diagonals is they split in half, so that 16 now becomes an 8, and they intersect at a right angle. So what that shows us, bada bing, bada boom, all comes down to Pythagorean theorem. So if I pull that little triangle out, okay, and I'm going to try to show you just kind of like I would right here. Okay, that's 8, that's 15. So if we find this guy, which is this guy, it's also going to be the same as that question mark. Okay, so you can see that we are finding the leg of a right triangle. So we have 8 squared plus b squared equals 15 squared. B squared equals, hopefully you can do this in my head and you're just going to kind of check. Okay, I get 161, and so that's not a perfect square. So I just want you to leave your answer as the square root of 161. Okay? So that means those two question marks are the square root of 161. So since we had 2 of them to make the whole diagonal, it's going to be 2 times the square root of 161. Okay, so I'll show you how I would key this into my calculator. So we have 0.5 times 16 times 2, and you don't even need to use parentheses really because it's all multiplication. 161, enter. So I think it wants this to the nearest square unit, so that would be 203 inches squared. Now, this will not be an extra credit question on your test, I believe, so you want to make sure you study number 9. Okay? And number 10, we have a special right triangle, so we're finding OB, side OB. So we first realize what triangle we have. It's a 45-91, so we are given the hypotenuse. Okay? So that means x over the square root of 2 equals 10. We want to start solving for x because that'll give us the side length. So divide by square root of 2. Divide by square root of 2. X equals 10 over the square root of 2. And now that's a big no-no. So square root of 2 times the square root of 2. So we're still at x equals 10 square roots of 2 over 2, and you're going to have to simplify that to 5 square roots of 2. And that is the side we need to find, so the length of OB is 5 square roots of 2. Okay, so what you need to do is think about the questions that were the hardest for you. You need to list them below, and then up on the board you'll see, if you thought number 10 was hard, it tells you what problems to do on the next assignment. If you thought number 1 was hard, it tells you what problems to do. So the goal is that you think about, your strengths and weaknesses and decide what you need to practice.